Okay, good morning to one and all. Good morning, students. I hope you are doing great. Welcome to the sisyaclass. Myself, this is Satish. I hope you are all fine and safe in your houses, and you are preparing well for your final exam, final board exam. Today, we are going to start the topic on probability, and we are going to see how the probability goes. What are the different problems we are going to solve in the probability, and this is our maths exam final countdown, where we have explained few lectures before. Till yesterday we have explained few more lectures, and today we are going to learn about the probability, and tomorrow also, and day after tomorrow we have 2 more days. We will try to do as much as possible in the last countdown. We have covered almost all the topics that is relevant to the 10th board exam. I hope you enjoy and like, and also you get enough knowledge through these lectures. Right. Okay. Right. I would like to briefly explain about myself. My name is Satish, and I have done my masters from IIT Palakkad, and I have over 5 years of experience, and I have taught around 50,000 plus students. Okay. So this is a brief introduction about myself. Without further go, we would like to start and dive into the topic. Right. Okay, so in today's class we are going to discuss what is a probability, and we are going to discuss the definition of a probability, and we are going to see several nomenclatures in the probability. That is, what is an event, and we are going to discuss what are the different types of event, and we are going to solve few problems which has occurred in the previous year's exam, right? Previous year board exam. So this is how our framework for the today's class is, right? Okay, so okay, what is this probability? And have you ever confronted this? What is this probability? Have you ever seen this? Maybe when you are talking with your friend during the cricket match, you might be being a judge in a cricket match. You might be saying to your friend, ki most probably today India might win, right? Or most probably the Pakistan might lose. Okay, so you might say there is a 50-50% chance. Okay, if you go to a board exam, or if you go to if you have written an exam, after coming back to the exam, after coming from the exam, you say to your friend that okay, my paper went okay, there is a 50% chance that I will pass the exam. Okay, so that is how you just describe unconsciously something related to a mathematical subject. That is a probability. You are in a position actually to see a situation, to say about a situation which is going to occur in the future. You are going to discuss the percentage of it. You are going to say there is a most probably, right? And at times you might also have seen, right, even seeing at the sky, at times you might also say that today there is a chance of falling a rain, right? There is a chance of a rainfall. This is how you predict few things, right? It is not a horoscope. It is just a prediction that it might possibly happen. Okay, there is some percentage of chance that this is most likely to occur. Right? Now this is where we have unconsciously discussed about the probability. This is where we are seeing the probabilities. Right? Now let's see where we have actually seen this probabilities. See, in India versus Pakistan match, you might have seen, especially in the CricBuzz Live or in the live score in the Google, you can see that there is a 70% chance and 30% chance that the Pakistan might win, and the India might win 70% chance. This is the win probability, right? This is where we have seen. Okay, this does not give us an assurance, but this says an approximation or a prediction where it is most likely to happen. Right? So this is what we see even in the IPL matches also. Even in the middle of the game, we could see there is some fluctuation in the percentage, right? There is some 70-30, 75-25. As we are getting closer to the end of the game, there is this prediction would be much more precise, right? Right now, we would like to further go into the next point. Okay, now you see, even we have seen even in the football matches as well, and even when there is a rainfall, right? Even when there is a rainfall, you could see that what, like you could see that there is a 70% chance of rain. Okay, there's a 50% chance of rain, right? The climate might be sunny. So this is the chance of thing that that they come to a conclusion through the probability, right? Even before the starting of the match, they using the weather forecast, they would say that there is a chance of having a rainfall during the match. Okay, so that is where we get this prediction even before the match, right? So we see this sort of a things, especially in the games, especially in predicting some things which we have no idea about, right? Which we have no idea, which we cannot conclude in between, which we cannot acknowledge in before, but we could predict approximately what could be the possibility, right? This is where we have seen the probability is. Now, I would like to formally just say what is a role of probability in the section of mathematics, right? So, a branch of mathematics that measures an uncertainty of occurrence of event and outcomes. So, that is what we have discussed till now. We are trying to formally define in terms of English, right? This is something like which we are going to measure. There is an uncertainty. We don't know. We are not certain about it. We don't know what exactly is going to happen. But we are coming to a conclusion that this might most probably happen, right? So that is what uncertainty of an occurrence of an event. It is a measure of uncertainty of occurrence of an event or an outcome. So that is what we have discussed till now, right? Okay. Now, you see, in a probability, right, there are few terms that we need to understand. Okay, it is just like that we need to be a little more conscious about it, right? And we need to be aware of the terminologies that are involved in the probability so that we can understand it much more transparently, much more clearly what exactly is meant by a probability. Okay, first, a random experiment. Okay, what is meant by this random experiment? An experiment is called random experiment if it is satisfying two conditions. Okay, now when we can use like a random experiment means, see, suppose there is a match. Okay, you know that there is a like you don't know the result of the match, right? You don't know what the result would be, right? So that is the first thing. What is meant by a random experiment is it has two conditions. First, you cannot predict the result in advance, right? You cannot predict the result in advance, but for that experiment, there are some possible outcomes, right? So these are the two conditions in which you can say what is meant by a random experiment. So see, that is what it can say. So what is a random experiment? It is not possible for you to predict the outcome of in advance. You cannot predict exactly what is the result of the match, right? You cannot predict whether India is going to win or lose, whether that is, you cannot predict 100%, right? Till the last ball you cannot predict, right? But there are some chances, right? What are the possible outcome? What are the possible outcome even before playing a match? There are possible outcomes, right? Either India might win or India might lose, or there is also a possibility that there might be a draw match, right? So these are the different outcomes that a random experiment, that an experiment could possibly have. So first is what you can, it has some possible outcomes, that is the first point, and it has, like, we cannot predict the result in advance, right? But we can clearly somehow manage to say that this is most likely to happen, right? So that is what this random experiment says, right? Okay. Next, what are the total outcomes? So next, what is a total outcome? A total outcome is what are the different possibilities that an experiment could have, right? Till now we have discussed, right? There are certain possibilities, there are certain outcomes that a particular experiment might have, right? So if you go for an exam, either there is a possibility that you might pass or fail, right? These are the outcomes that an experiment will have. So this is nothing but the total outcome. The set of all possible outcomes of a random experiment is called sample space, and it is also denoted by S, and these are called the total outcomes, right? So this is what it is meant by the total outcomes. Next, we are going to take few examples. What is like, for example, a random experiment? You already know, you are a little bit aware about this concept even from your childhood classes, that if you are trying to flip a coin, right, there is a chance of getting a tail or a head, right? So this is a random experiment. So what does a random experiment has? Random experiment, it has two conditions, right? It has two conditions. What are the two conditions it has? First thing, there are possible outcomes, right? There are some possible outcomes, right? And you can never predict the result. You can never predict the result in advance. You can never predict the result in advance. You can never ever predict the result in advance. But this is what the random experiment says. So when you are flipping a coin, when the coin is in the air, can you just say what is the outcome of that in advance? Is it going to be head or tail? No, you cannot judge it, right? Unless and until we flip the coin, we are not able to judge, right? But there are only two possible outcomes, that is either head or tail, right? So there are some possible outcomes, yes, right? But you cannot predict the result in advance, right? So that is what the random experiment says, right? The next one, right? So what are the total outcomes, right? What are the total number of outcomes for tossing a coin? So if you flip a coin, either there might be a tail or a head. These are the only two possibilities that are possible under the gravity, that like only there might be a head or tail, right? Okay. Now let's see one more example. You might know already, like you might have played Ludo, right? You might have played snake and ladder even, right? Even during that point of time, you might have used this die, right? You might have used this die. You need to roll the die. There would be some number in which you will be going from one point to the another point, and then the game goes on like this. Even in the Ludo, even in snake and ladder, where you will be jumping from one point to another point, right? But is it something related to the probability? How it is related? Why are we talking about die? Because when you hold a die and when you just roll a die, right? When you roll a die, can you predict the result in advance? No, because you have no idea what exactly and how is the die going to turn out to be, right? It is completely, it is very accidental. We don't know. And at times, like when we are challenging with our friend, we would be very, we would be excited enough that for that one number to complete our game, we would be excited, but we would be struggling to get that one number, right? So that is what we would be doing in rolling a die. When we are rolling a die, we don't know our result in advance. We cannot predict. But surely, when you roll a die, there is a chance of getting a number from 1 to 6, right? There is a chance. On a die, you know that the die, when you roll, there is a chance of getting 1 to 6. So is this a random experiment? Yes. So can you all say what are the different outcomes of this random experiment are? Can you please type it out in the chat box? What could be the different outcomes that this rolling a die that could be possibly having? Right? When you're flipping a coin, there are two possible outcomes, that is either head or tail, right? But when you are rolling a die, there are also certain possible outcomes. I hope all of you are writing the comments in the chat box, right? Please write your comments. I want to see how many outcomes are there. What are those outcomes also I wanted to know, right? What are the different possible outcomes that a die could possibly have, right? Okay, I hope you have written the comments. Like, there are 6 outcomes, right? A die comprises of 6 numbers, 1, 2, 3, 4, 5, 6. Now, these are the outcomes when you are rolling a die, right? These are the total possible outcomes when you are rolling a die, right? Okay, now let's further go. Till now, we have understood what is a probability, and we have understood from our daily life examples where all probability we have actually used it, and then we have actually seen some real life gaming examples like rolling a toy, flipping a coin, and now we are going to go further, right? We are going to understand the terminologies in probability. Okay, so the first thing that we are going to learn is event, a specific set of outcomes for a random experiment. Okay, so if you are rolling a die, okay, so there are some possible outcomes, right? 1, 2, 3, 4, 5, 6. Okay, 1, 2, 3, 4, 5, 6. Right? Similarly, when you are flipping a coin, there are some possible outcomes, right? Among this, Now I can create an experiment, or I can say when there is a chance of, for example, when you are playing a game, there is a chance of winning or losing. So an event is, I can say that what is a chance of winning. So that is an event that I have created, right? Okay. Or else now when I'm rolling a die, what is the probability of getting an event? I'm creating an event of even numbers, right? And so like that, I can create n number of events. That is, actually you can create 2 to the power n events, in fact, right? So there are some ways in which you can create an event, and then you can also find the probability for that particular event, right? So the events are a set or the subset of this numbers, or you can say they are the specific numbers in a in an experiment, right? And what is meant by a favorable outcome? Those outcomes which satisfies the event is called a favorable outcome. Okay, right. Now let's understand purely in terms of mathematics how is probability defined. Instead of now we have abstractly, or we have been scattered with the definition of probability by day-to-day life examples, but actually how exactly we define in terms of mathematics, right? So a probability is defined as the ratio of the number of outcomes favorable to the event E and or by total number of outcomes. That is, you can just say in much more simpler language, that is favorable outcome by total outcome. Favorable outcome by total outcome, right? Favorable outcome by total outcome, right? So this is how you define a probability, right? Okay, now let's understand the probability by solving some examples. Okay, now see here, find the probability of getting a head when a coin is tossed once. Okay, find the probability of getting a head when a coin is tossed once. Now when you toss a coin, okay, can you say what are the total number of outcomes? What are the total outcomes? First of all, what are the total outcomes? What are the total outcomes? What are the total outcomes you have when you are tossing a coin, right? We have seen when you are tossing a coin, we have only 2 outcomes, right? That is head or a tail, right? Head and a tail, right? So can you say how many number of outcomes we have totally? We have 2 outcomes. We have totally how many number of outcomes? 2 outcomes. So number of total outcomes is how much? Is 2, right? Total number of outcomes is how much? 2. Now he's trying to create an event here, right? What is that event? Getting a head. If you see, getting a head. So in this head and tail, how many heads we have? There is only 1 head. So what is our favorable condition to this event? What is an event? First of all, getting a head. How many heads are there in head and tail? There is only 1 head. So what is the favorable outcome? What is the favorable outcome? Favorable outcome is only head. Favorable outcome is only head, right? Now what is the probability? How did we define the probability according to the event? Here our event is getting a head, right? Here our event is getting head, right? Getting head. So I can define P of E, or I can also say that this is P of getting head. Okay, getting head. You can also write like this, or P of E. You can say, so how did we define the probability? Probability is defined as the favorable outcome by total outcome, right? Favorable outcome by total outcome. Okay. Now, what is our favorable outcome? Well, how many favorable outcomes we have? We have only 1. So the number of favorable outcome is 1. And how many total outcomes we have? We have only 2. So what is the chance of getting a head is 1 by 2. Okay. What is the chance of getting a head is 1 by 2. I hope you are all understanding this point very clearly, right? So when you are flipping a coin, there are 2 possibilities, that is head or a tail, right? The total outcomes are head or a tail. So when you are writing the sequence of step, you need to be clearly mentioning, right? What are the total outcomes you have? What are the possible outcomes for your favorable event? That is either a head or a tail, right? And then now you try to write probability of getting it is favorable outcome by total outcome, that is 1 by 2. This is how you actually give a clear framework when you are writing. Even if it is asked for 2 marks, also you need to be precisely writing in steps in order to get effectively the 2 marks, right? Now let's see to the next question. Suppose we throw a die once, okay? What is the probability of getting a number greater than 4? Okay, now please see this question very carefully. First of all, when you are rolling a die, without any further, first just write directly what are the total outcomes. Okay, without further thinking about the question, just write total. You write the total outcomes. What are the total outcomes we have? What are the total outcomes we have? When you roll a die, what are the total outcomes you have? 1, 2, 3, 4, 5, 6. You have how many? Totally 6. Can you say what are the favorable outcomes? Can you say what is the favorable outcome? Okay, so now let's read the first question. What is the probability of getting a number greater than 4? Okay, a number greater than 4. So can you list out from 1 to 6 what are the numbers that are greater than 4? What are the numbers that are really greater than 4? Can you just list it out? What are the numbers that are greater than 4? That is 5 and 6. Okay, that are 5 and 6. So can I say my favorable outcomes are 5 and 6? Yes? Yes or no? Now you can see, right? The total outcomes are how much? What are the total number of outcomes we have? So the total number of outcomes, is equals to how much? How many total number of outcomes we have? 6. How many total number of favorable outcomes we have? Okay, so you can say number of favorable outcomes is equals to 2. So what is the probability of getting a number greater than 4? So according to this event, probability of getting number greater than 4 is equals to, what are the favorable outcomes we have? 2. What are the total outcomes we have? 6. So you can write it in the simplest form, that is 1 by 3. Are you all following how the lecture is going on? How are we, we sequentially we are writing the steps, right? What is the first thing? We are writing total number of outcomes, right? Total outcomes. We are listing out what are exactly there when you are conducting an experiment. What are the possible total outcomes, right? Then for that particular event, what are the favorable outcomes, right? What are the favorable outcomes? That is number greater than 5, 5 and 6. Now how do you already know the probability formula, right? P of the is nothing but favorable outcomes by total outcomes. That is, we have how many favorable outcomes? We have 2 by 6, that is 1 by 3. Okay, so let's see the second part of the problem. Now you see, what is the probability of getting a number less than or equal to 4? Now what's the probability of getting a number less than or equal to 4? Okay, let's see this. Okay, we'll write here probability getting number less than 4, right? Less than 4. So how many total outcomes we have totally? 1, 2, 3, 4, 5, 6, right? Okay, what is the probability of getting a number less than 4? He's saying clearly the number is less than 4. So how many numbers are less than 4? If you observe, how many numbers are less than 4? 1, 2, 3. Can you all see this? How many numbers are less than 4? We have 3 numbers which are less than 4. So what is the probability? Now what is the number of favorable outcome? What is the number of favorable outcome we have? So the number of favorable outcome is 3, right? We have 3 different outcomes for this experiment, right? For this event, what are the numbers that are less than 3? That is 1, 2 and 3. So the number of favorable outcomes are 3, right? So now we have the probability of getting a number less than 4. So I'm just writing probability of getting a number less than 4. I'm just writing it as P less than 4 is equals to, you can say that is how many number of favorable outcomes we have? 3 by 6, which is equals to 1 by 2. Okay, I hope you're all following it. Great. Now let's dive into the next problem. Let's see how the next problem is going on, right? And let's understand this definition. Complementary event. Okay, complementary event. Now what is this complementary event? Okay, what is meant by this complementary event? Okay, now understand this. What is that which is not you? Okay, I'll say what is that which is not you. You say you touch your body, you say this is me. But what is that which is not you? Anything apart from your body is not you, right? That is what you define. A complement of you is nothing but apart from you the whole universe, right? A complementary event is something that which is not. It is not. Okay. In understanding in a very simpler terms, if I say, for example, if you're tossing a coin, I have created an event. Event is what? I created an event E. Okay, the event E is what? Getting a head. Okay, getting head. Now, I would like to say a complementary event for this. Now, I denote the complementary event by this bar. Okay, A bar. Okay, so event E bar. Now, how can you name this? How can you write the contradictory of this? Getting ahead. Can you say a contradictory statement to this? Right? See, for example, you are good. What is the opposite of the statement? Not good. Or you can say it is bad. Right? Similarly, getting ahead. What could you do? Just add this one small not to the statement. Right? It just get reversed. Not getting head. Right? What will be the complementary of this event? That is not getting head. Right? This is how you define a complementary case. Right? That which is not is called the complementary. Right? So if I say, for example, what is the probability of I have created an event that getting a number 4. Okay. So the event is what? 4. What will be the complementary statement for this? So if I have to create another event, for example, I have created an event A. Okay. I said A is nothing but getting number 4 on a die. Getting number 4 on a die. Okay. Now, what would be the complementary statement for this? What could be the complementary statement for this? The complementary statement for this would be not getting 4, not getting a number 4 on a die. Yes or no? Not getting a number 4 on a die. So this is called a complementary event. This is how you define. So the converse of a statement or the opposite of this particular statement is called a complementary of event. Remember this one point, the probability of an event and the probability of the complementary event is always equal to 1. The probability of an event and the probability of complementary event is always equal to 1. We would like to just justify this statement with an example, right? Let's see with an example, right? Now, let's see this. Suppose we throw a die once, okay? What is the probability of getting a number 2? And what is the probability of getting number not 2? Okay. So first case we would like to completely justify it. So here we would like to directly write this. What are the favorable outcomes on a die? What are the favorable outcomes? What are the favorable outcomes? We have 1, 2, 3, 4, 5, 6. We have how many favorable outcomes? We have 6. Now, what is the probability? Now he's asking what is the probability of getting a number 2? So so this is the total outcomes. This is the total outcomes we have. So the total outcomes is how much? Total outcomes is 1, 2, 3, 4, 5. And what are the favorable outcomes we have? Favorable outcomes we have is what are the favorable outcomes? It is only 2. So what is the probability of getting a number 2? Getting a number equals to 2. So what are the favorable outcomes we have? 1. And what are the total number of outcomes we have? 6. So the answer is 1 by 6. Are you all getting? So this is how you define, this is how you actually find the value for getting an event of probability 2. Right. Now let's define this event to be E. Okay. Let's define this event to be E. Okay. So the P of E is nothing but the 1 by 6. Now let's see what is the probability of getting number not 2. Okay, can we write for the second case? Can we write for the second case? What is the total? What are the favorable outcomes for the second case? So I'm just mentioning this as E, and I'm just mentioning this as E bar. Can you all consider this as a complementary event? Yes, this is a complementary event, right? So P of E bar is equals to, you can say, now what are the favorable outcomes? What is the event E bar says? Not 2. It is not 2, right? So what are the favorable outcomes according to this condition? Favorable outcomes are, it is 1, 3, 4, 5 and 6, right? How many we have totally? So total number of favorable outcomes are 5. What is the probability of E bar? Okay, that is the complementary of this event. That is, how many we have numbers? 5 by 6. Now, can you see that if you add P of E and P of E bar, let's try to add these two values. P of E plus P of E bar. Can you see there is something beautifully happening, right? See, P of E is 5 by 6 and P of E bar is 1 by 6, right? So P of E is 5 by 6, P of E bar is 1 by 6. So if you try to add, that will be 6 by 6. So that will be 1. So that will be equal to 1. So this is how our question has gone. So understand this clause. This is very, very, very important. Whenever you have to find a complementary of an event, you always remember this relation. P of E plus P of E bar is equals to 1, right? So whenever we have to do, if you can find the event of P of E, that is the one of the event probability, the complementary event, you just need to subtract 1 from that, right? You can rewrite this equation like this. P of E bar is equals to 1 minus P of E. Can you all write this, right? This is how we can write the relation between a complementary event and an event, right? Now, let's see the next question. Now, see this question. This was asked in 2024 exam, right? This is a MCQ question. If the probability of winning a game is P, then the probability of losing the game is. What is the probability of losing a game? Okay, so don't you think probability of winning and probability of losing? So when there is a game, what would be the complementary event for the winning? Not winning. Not winning means it is losing. Yes or no? If my event is winning, if my event is winning the game, right? If my event is winning the game, so what would be my event of losing the game? So what will be the complementary of this event? That is not winning the game. Not winning the game, right? It is not winning the game. So you already know that probability of these two events. So if I say that probability of winning a game is, he has already said it is P. Okay. Now you already know the relation between the complementary and the event, right? So can I write P of E complement is nothing but 1 minus P of E? But you already know the value of P. P of E is nothing but 1 minus P. Hence, what is the answer we have? 1 minus P, right? Okay. I hope you are very much clear with the concept of the event and its complementary. Complementary is nothing but the not. Okay. Right. Now, you see, two dice are tossed simultaneously. Find the probability of getting an even number on both dice. And the second case is sum of two numbers is more than 9. Now, understand this question very cleanly. Let's try to first write down whenever we see a question on probability. Without even further go, you need to first blindly think about this total number of outcomes. What are the total possibilities that an experiment could possibly have, right? Now, there are two dice tossed simultaneously. So you might have seen, even in this Ludo game, you might have rolled two dice. But you could see several combinations in which these two dice play, right? At times there is like 1, 1, there is 1, 2. You can see that thing, right? So there is 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, right? So similarly, so what does this 1 first signify? This signifies the number on the first die. What does the second number signifies? It signifies the number on the second die, right? This signifies the number on first die, and this number signifies the number on the second die, right? So that is the possibility, right? On the first die you might get 1 and the second die you might get 5, right? Or 6. Like these are the different outcomes. Not just that, maybe there are so many other outcomes also. 2 1, 2 2, 2 3, 2 4, up to so on 2 6, right? Like this you can just write down 3 1. I'm just keeping here. I'm just writing down all the possibilities, listing out all the possibilities once for you all, so that you don't get confused. What is these numbers? How are they related and all? Okay, so okay, 4 4, 4 5, 4 6. Similarly, again you have the sequence of 5 1, 5 2, 5 2, 5 3, 5 4, 5 5, 5 6. Similarly, you have again 6 1, 6 2, 6 3, 6 4, 6 5, 6 6. So can you say me how many total number of outcomes we have? That is 6 into 6. There are totally 36 outcomes are there in this experiment, right? These are the total number of outcomes that this experiment of rolling a die has, right? Now, let's see what is he asking. Now, let's try to see here itself. Completely, we'll try to picture it out here itself. So, these are the total outcomes, right? Now, he's asking the probability of an even number on both dice. So, when can we have a probability of even number on both dice? What is the possibility? What are the probability? So, on the first die there should be an even number. On the second die also there should be an even number, right? So, if you see here this 1 1. Here if you see here 1 2. So, these are the odd numbers. This is an odd number. Again this is an even number. Now, if you see here, this is an even number, right? But this is not an even number. So, this is not the case, right? So, you need to search for the numbers where both are even. So, that is, if you see in this case, 2 2, 2 4, 2 6. Yes. Similarly, 4 2, 4 4, 4 6, 6 2, 6 4, 6 6. So how many we have? Totally, how many number of possible outcomes we have? We have total possible outcomes is how much? That is 36. And what is the probability? That is, what is the probability of an even? What are the favorable outcomes we have? 2 2, 2 6, 4 2, 4 6. There are totally 6. So for the first problem, if you see for the first problem, what is the probability of this event E? I'm just discussing about this event E. Let's say this is E. Okay, so this is nothing but what are the total outcomes we have? They have total number of outcomes as how much? That is 36. And what is the favorable outcome we have? How many we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 outcomes. So can you do it in the simplest form? That is 9 by 36, which is equals to 1 by 4. Okay, now you see the next case. Sum of two numbers more than 9. Okay, if you add both numbers on the die, the result should be greater than 9. Now, please be very conscious about this. I'm just taking this as some P of, like I'm just taking P of A. I'm just naming this event as A. You can name anything. Okay, you can name it as E, A, B, C, anything, your wish. Okay, so sum of the two numbers is more than 9. Okay, it should be not equal to 9. It should be greater than 9. So if you see here, this is 1 plus 6, 7. So all these are well less than 7, less than 9 itself. If you see 2 plus 2, 4, 2 plus 4, 6, 2 plus 6, 8. At max in this row, you can get only 8. But if you see the next one, 3 plus 3, 6, 3 plus 4, 7, 3 plus 5, 8, 3 plus 6, 9. You don't need the number, sum is 9. If you add these two numbers, you are getting the result to be how much? If you are adding these two numbers, if you are trying to add, the result is what? 9. But you want the number that is greater than 9, that is more than 9. When can you have the result more than 9? That is, see, the first one is, I would like to highlight it here and clearly. See here, what are the numbers that are sum is greater than 9? 4 plus 4 is 8, 4 plus 5 is 9. So these are all discarded. So the last one is 4 plus 6, 10. So again you can see 5 plus 2, 7, 5 plus 3, 8, 5 plus 4, 9, and you can see 5 plus 5, 10, 5 plus 6, 11. and again you can see 6 plus 4 10, 6 plus 5 11, 6 plus 6 12. So how many cases we have? 1 2 3 4 5 6. So what is the probability of getting this event that is more than 9 is how much? 1 2 3 4 5 6. So that will be 6 by 36. So the answer is 1 by 6. So are you all understanding how did we completely understand this problem, right? Simply you don't have to do any complications in this. First you need to list out the favorable outcomes, and first you need to list out the total outcomes. Among the total outcomes you need to also write what are the favorable outcomes, and then you need to find the probability, right? This is how the problem goes on. Right, now you see the next question. Two dice are tossed simultaneously. Find the probability of getting an even number on both dice. The sum of two numbers is more than 9. Okay, okay, now you please see this question on the cards. Okay, now we have this cards is one of the important concept when we are understanding the probability. Okay, now not familiar with the game, but we'll try to understand the total infrastructure of this cards. Like we'll try to see what are the total number of things that are available in this cards. These are the playing cards. These are in total there are 52 cards. Okay, there are totally 52 cards. In this there are two color cards, that is there are two dissection of cards, that is the black cards and the red cards. We have the black cards and we have 26 red cards. Together we have how much? That is 52 cards. Okay, there are totally in total how many cards we have? We have 52 cards. Among this you can see the spades, right? The black cards are divided into two dissections, that is spades and club, and the red cards are divided into hearts and diamond, right? There are 4 dissections, and in each pair of this 4 we have totally 13 cards. Each card has, it is starting from the A 2 3 4 5 6 7 8 9 10 jack, queen and king, right? We have jack, queen and king. So these 3 cards are called face cards. What are they called? Face cards. Okay, these are called the face cards. Now this similar thing is there in every pattern, right? It is there in spades, it is there in clubs, this is there in diamond, this is there in 13. The uniformity is there in terms of these pairs, right? But these are having some different color and different shapes. So again I am repeating once again, there are totally 52 cards in which there are 26 black cards and 26 red cards, right? In this 26 black cards there are 13 of spades, 13 of clubs, 13 of diamond and 13 of hearts, right? Now this is how we justify. So can you all say what are the how many number of face cards do we have? Total number of face cards do we have? Can you just say, just what to whatever extent we have learned? See, in one sequence of this spades there are 3 face cards. How many face cards do we have here? 3. Here also there is 3, right? Here also there is 3 and here also there is 3. 3 plus 3 plus 3 plus 3. 3 4s are 12. So how many face cards do we have in total? We have 12 face cards, right? Okay. Now this is a small introduction about the cards. Now let's try to solve some problems based on this deck of cards. Okay, now let's see. Okay, so one card is drawn at random from a well shuffled deck of 52 cards. Find the probability that the card is a red king, not a black card, and ace of hearts. Okay, now let's try to completely dismantle the statements one by one. First you see how many number of cards do we have? Totally 52 cards. Okay, now a red king. So let's go back to the problem. Let's see how many kings are there. Okay, so if you see here how many kings, so how many red cards do we have? 26. So the king is there in each and every sequence, right? In spade there is a king, in club there is a king, in diamond we have king, and even in heart we have king. But how many red kings do we have? We have 2 red kings. Yes or no? In diamond 1 king is there, and in when heart is also 1 king is there. In totally how many number of red kings do we have? In total we have 2 red kings. So what is the favorable outcome we have? That is 2 red kings. So the probability for the first one, okay, for the first one, probability of a red king is how much? Is what are the what are the favorable outcomes we have? 2. And what are the total outcomes we have? 52. So that will be 1 by 26. That is 1 by 26. Next, next you see the next one is not a black card. Now, when can you say not a black card? So, do you remember this event called complementary event? There are two events. Like for example, whenever this not comes, it is something talking about the complementary. But anyway, in the deck of cards, how many cards do we have? Totally 52. In this, how many red and how many black we have? We have 26 black and we have 26 red, right? Now, he's saying what? Not a black card. That means what? It's a red card, right? So, that you can say, instead of saying probability of not a black card, probability of not a black card is nothing but, you can say, in terms of complementary, let's try to understand it much more rigorously for the complementary event. Can I say that 1 minus probability of getting a black card? Can I say like this? Can I clearly picture out like this? Right? This was asked in 2023 exam, the same question, right? So what is the probability of getting a black card, right? How many black cards do we have? We have totally 26 black cards. So can I say that 26 by 52? Yes or no? So which will be 1 by 2. So can I say 1 minus 1 by 2, which is 1 by 2. Can I say this is the probability of not a black card, right? This is how you find using a complementary concept, right? Complementary event concept. Okay. Now you see an ace of hearts. Now what is meant by this ace of hearts? Okay, let's see this picture. Okay, heart is there. How many cards are there in heart? There are 13 cards. In that, how many aces do we have? We have only one ace, right? When he says aces of heart, how many we have? We have only one. So what is the probability of getting an ace is how much? Is nothing but 1 by 52. Is nothing but 1 by 52. I hope you are all understanding this about the deck of cards. It is very simple. If you try to understand the whole frame, you don't even have to again remember this. You just need to understand that the 52 cards, how it is being divided. It is very simple. And probability is one such section where you can score the marks very easily. If any 1 or 2 mark question is also given, make sure that you don't lose marks in probability, because it does not have any sort of an arithmetics. It is just that you just need to write 2 steps and get the answer, write the answer in the simplest form. That's all. That's all. It is very simple, right? Now, let's see the next question. Again, it is related to the cards. From a well shuffled cards, now this is what little more tricky. It is asked in 2024 exam. From a well shuffled cards of 52, a black queens and a red kings are removed. Okay, in total of 52 cards, there are 2 dissections. That is the black cards. There are 26 black and there are 26 red. There is 26 black and there are 26 red, right? Among the black cards, there are further dissection, that is, we have spades, we have club. Okay, we have spades, we have club. Okay, and in this also there is furthermore dissection, that is, we have hearts and diamond, right? So in this, he is trying to remove the black queens. So how many queens are there in the black? There are 2 black queens, right? There are 2 black queens. 2 black queens are there. 2 black queens. So these 2 black queens are removed. Okay. Similarly, he's also removing one more thing, that is red kings. So red kings. So this red kings are also completely removed. Okay. So how many 2 black queens? There's 1 queen over here, 1 queen over here. There are 2 cards gone, and there are 2 red kings over here. So those are also gone. So totally how many cards have been removed from this deck of cards? 4. So what are the total number of cards that are left out? That is 48. The totally how many number of cards do we have right now? We have 48. Now you see, what is the probability of getting an ace? How many aces are there totally? There are total number of aces. So our new total outcomes total outcomes, number of total outcomes is how much? Is 48. Now in this, what are the total number of aces we have? How many aces we have? We have 4 aces, because from each thing we have 1, 1, 1, 1. We have 4 aces. We have never ever removed the aces from this. We have removed only 2 black and 2 kings. So for the first one, the probability of getting an ace is how much? Ace is how much? It is 4 by 48. Are you all getting? So I'm just writing in the next picture. So probability of aces is equals to how many number of aces we have? So the number of aces you write here, and total number of cards. Total number of cards. How many number of cards? How many aces we have? 4, and total number of cards are how much? 48. You will be again. You don't go with the flow of 52 because 4 cards have already been removed. So 4 12s are. So the answer is 1 by 12. Right? Now you see the next one. Right? You see the next one. What is the next question? He's asking jack of red color. Okay. How many jacks are there? There are here. There is 1 jack over here, 1 jack over here. 1 jack is there in the heart, 1 jack is there in the diamond. How many total number of jacks we have? We have 2 jacks. Right? So probability of getting a jack, even red jack of red color. So you say, what are the total number of red jacks, that is by total number of cards. How many red jacks we have totally? We have 2 red jacks and out of 48. So that will be 1 by 24. Okay. Now you see the last one, the king of spade. Okay. In a spade, the spade, remember this very, very carefully. The spades and clubs belong to the category of black cards, and hearts and diamonds belong to the category of red card. From the black cards, we have removed the queen, not the king, right? And from the red cards, we have removed the king, right? Now, the king of spade belongs to which category? It belongs to the black, right? Now, in the king of spades, there is a king sustaining still there. He's still available there, right? He's not been removed yet. Now, that king is how many kings we have in spade? We have only 1 king. So that will be 1 by 52, 1 by 48 again. King of spade. So again the answer is the number of spade kings. Okay, number of kings in spade by total number of cards. Total number of cards. So how many kings we have in total? We have totally how many kings we have? We have only 1 king of spade by 48. So this is how you clearly write your answer. Make sure when you're writing the answer, you write it in a sequence of steps. Don't conclude your answer in one line. Write down everything very clearly. Right? Now, see here. Now, there is a letter called mathematics. Okay? Please read the question. A letter is chosen at random from the word mathematics. What is the probability that it will be a vowel? What is the probability it will be a vowel? Can anyone say what is the probability of being a vowel? So, mathematics. Okay. You know vowels? What are the vowels we have in mathematics? Okay. What are vowels first of all? What are vowels we have? We know the sounding in English, right? We have A, E, I, O, U. We have 5 vowels. In total, there are how many vowels we have? 5 vowels, right? We have totally how many vowels? 5 vowels. But in the whole of mathematics, okay, if you see how many letters are there, first of all, total number of letters. Total number of letters. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. We have how many letters? We have 11. Okay. What is the probability that it will be a vowel? Okay. What is the probability it will be a vowel? So, how many vowels we have? So, number of vowels. Number of vowels. How many vowels we have? A, E, A. Okay. This is a consonant. Okay. So, this is a consonant. This is a consonant. Okay. This is a consonant. So this is not the case. This is a vowel. This is a consonant. H is a consonant. E is a vowel. M is again a consonant, A is a vowel, T is again a consonant, I is a vowel, C is a consonant, S is a consonant. So how many vowels we have? A, E, A, I. So we have total number of vowels, we have how many? We have 4, right? 4 vowels we have. So what's the probability of getting a vowel? Of having a vowel is how much? That will be 4 by the total number of outcomes, right? 4 by 11. Okay. Now let's go to the next thing, next part of the phase, that is event. And we are going to, as we have discussed what is an event, now we are going to see what are the different types of event, right? So the first one is we are going to discuss is impossible event. Now what is this impossible event? Okay, the event which is impossible to occur. So there is no chance that an event can occur, right? There is not at all a possibility that this event could possibly occur, right? Well, let's take an example. What is the probability of getting 3.5 on a die? So on a die, what are the different numbers we have? 1, 2, 3, 4, 5, 6. We have 6 numbers. But is there a number called 3.5? No, there is no such number that is existing, right? So definitely this sort of an event could never occur in whichever the way you throw the die, right? So the probability of getting a number equals to 3.5 is equals to how much? 0. Probability of getting a number 3.5 is how much? Is equals to 0. I hope you are understanding the whole thing of the impossible event, which is never ever going to occur whenever you throw a die. Okay, so that is what I went to say. Okay, now the next one is sure event. Okay, now if you see here, what is a sure event? An event which is sure to occur, which is definitely going to occur, is called a sure event. Okay, so just see what is the probability of getting a number less than 7 on a die. On a die. Okay, if you roll out a die, what is the probability of getting a number less than 7? So how many numbers we have on a die? We have 1, 2, 3, 4, 5, 6. Do you think all these numbers are less than 7? Yes or no? We have how many number of numbers are less than 7? 6. And what are the favorable outcomes on a die? That is 6. So what is the probability of getting a number less than 7 is 6 by 6, which is equals to 1. Right? Isn't it very simple? Right? This is called a sure event. Right? And remember this note point very, very carefully. Okay, always the probability value oscillates, or it just goes between 0 and 1. Okay, it just moves from 0 and 1. Okay, so this is where the probability of an event lies, right? It either starts from 0, or it could be maximum value that it can occur is 1, right? And all the values will be between the decimal of 0 and 1, right? So that is what a sure event is, right? Next, the next one is simple event. An event which is having only one outcome is called a simple event. What is a very general example? If you flip a coin, getting a tail, isn't it a simple event? It has how many outcomes for that event? There is only one outcome. So that is a simple event, right? Now, for, that is what a simple event means. Similarly, a compound event, an event which has more than one possible outcome, For example, when you are rolling a die, what is the probability of getting an even number? So this is an even number, right? So event is an even number on a die. So how many numbers are there on a die? We have 3 numbers on a die, right? So this becomes a compound event. Okay, right. Now please see here, we'll try to wrap it up. 3 coins are tossed simultaneously. What is the probability of getting at least one head, exactly 2 tails, at most 1 tail? Okay, there are how many heads do we have here totally? How many coins we are flipping? There are 3 coins we are flipping. First, we'll try to write the favorable outcome. So what are the favorable outcomes we have? We have head, 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 right? If you try to flip a coin, the next one is head, head, tail. The next one is head, tail, head. The next one is tail, head, head, right? The next one is the tail, head. The next one is tail, head, tail. The next one is tail, head, head. And the last one is tail, 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 right? How many we have? 1, 2, 3, 4, 5, 6, 7, 8. How many totally favorable outcomes we have? Total favorable outcomes we have 8. Among this, he is saying at least 2 head, right? At least 2 head. So what is meant by this word at least? What is meant by saying at least? That means minimum 2 or it can be more, right? It should be minimum of 2. Understand these two words called at least and at most. At least means minimum, like in Hindi we say kam se kam, right? Minimum it has to be 2 and it can go more, right? And at most means the maximum it could be 2 and or it should be less than 2. Are you all understanding at least and at most means? So there should be at least 1 head. So what are the cases that there are at least 1 head? So first we'll see where there is only 1 head. Okay, let's try to see how many heads we have here. 3 heads. Okay, first we'll try to write only 1 head cases. Okay, tail, head, tail, head, tail, tail. Okay, tail, tail, head. Okay, there is only 1 head here, but he's saying at least, right? That means there can be more than 1 head. That is head, head, tail, head, head, tail, head, tail, head, head. So how many heads we have totally? Here 2 heads we have. Here we have only 1 head, right? And the last one is, it can have even all the heads also. So what is the total number of heads we have? We have total number of heads is 7. So that is, what is the probability of getting a head? At least 1 head. At least 1 head is how much? That will be, total number of outcomes is 7 by 8. So the favorable outcome is, these are the favorable outcomes. We have 7 and the total outcomes is how much? 8. So 7 by 8. But you all can do one thing is, you can try out this problem using the concept of complementary event. Okay, so you can just go back and do this concept. At least 1 head, can just think about what could be the complementary event of at least 1 head. Okay, so that you need to think out and just come with a solution in the other pattern. Okay, now exactly 2 tails. So how many number of 2 tails we have? So he's saying the second event is exactly 2 tails. Okay, let's try to write the event to be exactly 2 tails. Exactly 2 tails. So how many are there with exactly 2 tails? Okay, so tail, tail, head. Okay, so wait 1 second. Tail, tail, head, tail, head, tail, head, tail, tail. So how many we have? We have totally 3. So what is the probability of getting exactly 2 tails is how much? We have probability of, I'm just writing it as B, is 2 tails is how much? We have 3 by 8. Yes, simple. Isn't it very simple? Writing the favorable outcome and then again writing the total outcome. At most 1 tail. So the next one is at most 1 tail. Okay, at most 1 tail. Understand this, the maximum it could be is only 1 tail and the minimum is it cannot have any tail at all. Okay, so what will be the total probability? How many ways in which it can have at most 1 tail? That means there should be 1 tail that is considered. Okay, so the tail, 1 tail is considered, right? 1 tail is very much considered, right? And what about the last one? What is the 1 tail is definitely getting considered. And the last one is either no tail is also possible, right? At most 1 tail means either it should be 1 tail or it can have 0 tails, that it cannot have any tail at all. So that is what the at most 1 tail is. So how many outcomes do we have? We have totally 1, 2, 3, 4. So we have 4 by 8. The answer is 1 by 2. I hope you are following the lecture. I hope you are doing everything very smoothly. You are understanding very clearly. Let's go to the next question. A cartoon consists of 60 shirts, of which 48 are good and 8 have major defect. So just underline these keywords. 8 have major defect and 4 have minor defect. Okay, there are total 48. Okay, Nigam, a trader, will accept the shirt which are good, but Anmol, another trader, will only reject the shirt which have major defect. One shirt is drawn from the cartoon. What is the probability that it is accepted by Anmol? Okay, so what does Anmol do? But Anmol, another trader, will only reject which has one major defect. Okay, will only reject if which has one major defect. What is the probability that it gets accepted? When will Anmol accept the order? So if there is even one major defect in the whole thing, he will definitely not accept it. But when will he accept? When there is not at all one major defect, right? So how many major defects we have? 8 major defects. So if he picks up a shirt which is not having a major defect, that is how not major defect. So probability, so first of all, Anmol accepts, you write this, Anmol accepts only when there is no major defect, no major defect of one shirt, no major defect, right? So how many shirts are there which are having no major defect? There are totally 68. 68 if you remove 8, so 60 minus 8, so 60 minus 8, that will be 52 shirts are there which does not have a major defect. So what's the probability that Anmol accepts? Anmol accepts is, that is nothing but the favorable outcome, 52 by 60. I leave this calculation of simplest form to your case. Okay, now please see, a bag contains 4 red, 3 blue and 2 yellow balls. One ball is drawn at the random from the bag. Find the probability that the drawn ball is red and yellow. Okay, so how many total number of balls we have? The total number of balls are 4 plus 3, 7, 7 plus 2, 9, right? What one ball is drawn at random from a bag. Find the probability the drawn ball is red. Okay, probability of getting a red ball. Okay, so how many red balls we have? We have 4 red balls. So 4 by 4 plus 3, 7, 7 plus 2, 9. So the probability of getting a red ball is 4 by 9. What is the probability of getting an yellow ball? Simple. Again, how many yellow balls we have? 2 yellow balls, right? 2 by 9, right? So this is how we find the probability, right? Cards being number 3 to 20 are placed in a bag and mixed thoroughly. A card is drawn out of the bag at a random. What is the probability that the number of the card taken out is an even number? First of all, don't get confused here, students. Please listen. 3 to 20, there are not 17 numbers. There are totally 18 numbers. Okay, 3 is also included in the number. Okay, if you count how many numbers are there from 3 to 20, there are 18 numbers. Okay, so the total numbers are how much? Total number of outcomes are how much? Is 18. Okay, what is the probability that the number on the card taken out to be an even number? How many even numbers we have? So what are the favorable outcomes? So our number starts from where? It starts from 2 is an even number, but 2 is not been considered here because it starts from 3. So 4, 6, 8, 10, 12, 14, 16, 18, right? And the last number is 20. So how many we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. So what are the total favorable outcomes we have? 9. So what's the probability of getting an even number is how much? 9 by 18, which is 1 by 2. Okay, so hence here we conclude our session on probability. We have briefly understood, very clearly we have understood what is a probability, what are the different terminologies, what are the different aspects that are there in the probability. We have seen rigorously what are with different examples, we clearly understood the concept of probability. So here I would like to end my session by saying that we would again meet in our evening session where we will be discussing about the previous year's important questions, and for now you all again revise the topic, topics whatever we have covered, the definitions and the problems, and in the evening session again we'll muzzle up our minds and we will try to come back, and again we will do some very important problems that are most likely to occur in 2025 exam. So okay, until then keep in touch. Please like our channel, share our channel and subscribe our channel, and thank you so much. Please subscribe to the sisyaclass that is available on the Play Store. I'll also subscribe to our YouTube channel. Thank you. Namaskaram.